So here is another question on properties of electromagnetic waves. So it is given that electromagnetic waves travel in a medium, at a particular medium, at a speed of 2 into 10 to the power 8 meter per second. The relative permeability of the medium is 1. Find the relative permittivity. Okay, so this is the question. So here the first thing which we have to do is the concept of velocity or speed of electromagnetic waves in a medium. So the speed of electromagnetic waves in general is given by V by 1 by root over of mu m epsilon m, where mu m is the permeability of the medium, that particular medium, okay, for the medium, which is equal to the product of the absolute permeability and the relative permeability of that particular medium, and epsilon m is the permittivity of the medium, that is equal to epsilon 0 epsilon r, where epsilon 0 is absolute permittivity, epsilon r is relative permittivity. So here if we express this, it will be 1 by root over of mu 0 mu r into epsilon 0 epsilon r. So we can rewrite it by rearranging them: mu 0 epsilon 0 mu r epsilon r, like this. Or we can again rewrite it as root over of mu 0 epsilon 0 into root over of mu r epsilon r. Okay, now we all know that for vacuum or air, the speed of electromagnetic waves is c, which is equal to 1 by root over of mu 0 epsilon 0, which is equal to 3 into 10 to the power 8 meter per second. So here this portion is equal to c, so we can rewrite it as c by root over of mu r epsilon r, this. Okay, we have already discussed this whole thing, this whole concept in properties of electromagnetic waves in that video, so you can watch that. So we get that the velocity of electromagnetic waves in general is equal to speed of waves in air or vacuum divided by product of relative permeability and relative permittivity. Here V is given 2 into 10 to the power 8 meter per second, mu r is given 1, epsilon r is asked, the relative permittivity. So we can square both sides, that implies V square is equal to c square by mu r epsilon r. That implies epsilon r is equal to c square by mu r V square, which is equal to 3 into 10 to the power 8 whole square by 1 into 2 into 10 to the power 8 whole square. So it is coming around, if we calculate, okay, it is coming around 2.25. So this is the relative permittivity which is asked, 2.25. Okay, this is the result. So the important concept here is to understand this formula, okay, remember it, and know how to manipulate it in different ways so as to get the desired result or the parameter which is asked in the question, okay, which we did. Okay, so here is another question on properties of electromagnetic waves. So it is given that a light beam traveling in the x direction is described by its electric field which is along the y-axis, which is expressed as Ey is equal to 270 sine omega t minus x by c. Then it is given that an electron is constrained to move along the y direction, that is in the direction of the electric field, and it is moving with a speed of 2 into 10 to the power 7 meter per second. We have to find the maximum electric force and maximum magnetic force on the electron. Okay, so now here so it is given that we have the light beam which is moving along the x-axis. Okay, the light beam is moving along the x-axis. The electric field variations, they are along the y-axis. So obviously the magnetic field, it will be along the z-axis. Okay, so now let us express first the electric field. Okay, then the magnetic field. Okay, this is the electric field, this will be the magnetic field. Both the electric and magnetic field vectors, they will be in the same phase, they will attain maxima and minima at the same time instant, same frequency, same phase, everything. And the propagation direction of the light beam is the propagation direction of the light beam is along the x direction. So the electron is moving along the y direction, sorry, the electron, this is the light beam direction, and the electron is moving along the y-axis. Okay, this is the direction of movement of the electron. So electric field is along the y-axis, electron is moving along the y-axis. The magnitude of the electric field is the amplitude, the maximum amplitude, that is equal to 270. Okay, 270 volt per meter or Newton per coulomb. Okay, so the force on the electron, the maximum force on the electron will simply be the electronic charge QE multiplied with the amplitude of the electric field, the maximum value of the electric field. So electronic charge 1.6 into 10 to the power minus 19 coulomb into 270 Newton per coulomb. So the result will be the force, the maximum force, that is equal to, it is coming 4.32 into 10 to the power minus 17 Newton. So that is the electric force. This is the maximum value of electric force. So it has also been asked to find the maximum magnetic force. So for that we have to determine the amplitude of the magnetic field B0. So simply we'll be using the relationship E0 by B0, that is equal to C. So B0 will be equal to E0 by C, where C is equal to the speed of the electromagnetic wave in free space. So 270 by 3 into 10 to the power 8. So it is coming around 9 into 10 to the power minus 7 Tesla. So this will be along Z axis. This will be along Z axis. So here we have to also determine the maximum magnetic force on the electron. So for that, if you remember, there is a formula, the magnetic force that is given by Q V B sin theta, which is, let us say we have a charge Q moving with a velocity v in a magnetic field of flux density B at an angle theta with respect to the magnetic field line. So here the magnetic field is along Z axis, the electron is moving along Y axis. So the angle of the electron movement with the magnetic field direction, that is equal to theta, is equal to 90 degree. Sin 90 degree is 1. So it will simply be QE VB, okay, QE VB, which is B0 here in this case, and the velocity of, or the speed of the electron is given 2 into 10 to the power 7 meter per second. Okay, the speed of the electron is 2 into 10 to the power 7 meter per second. So this force is equal to max, that is equal to 1.6 into 10 to the power minus 19, which is the electronic charge, into 2 into 10 to the power 7 into the maximum value or amplitude of the magnetic field, which is 9 into 10 to the power minus 7 Tesla. So it is coming around 2.88 into 10 to the power minus 18 Newton. Okay, so this is the maximum magnetic force. Okay, so this is the maximum electric force, which is 4.32 10 to the power minus 17 Newton, and this is the maximum magnetic force. So if you combine the electric force and the magnetic force, this will be called as Lorentz force. Okay, where a charge moves under the influence of both electric and magnetic field. Okay, so just to add on to this whole concept. Okay, so this is the thing.